is equal to the derivative. And that's the notation for a derivative. So I'm going to see if I can successfully, where did I just put my mouse? See if I can successfully show you this. I practice and practice and practice. There. All right. This is what I was trying. Is anything moving there? Or is it all frozen?
I believe the mouse is moving.
All right. So if you notice, I'm going to move this up so you can see it better. Here you have a point, x comma f of x, correct? Here you move a distance of 1.5 to the right. That's what I mean by the horizontal distance between 2 points. And I get, if this is whatever this value is, if I go 1.5 more, I have a new x value, this x plus h. When I plug that into f, it gives me a different y value, correct? And when I move this point, h decreases. And as that point gets smaller and smaller, that secant line is getting, is getting closer to the curve, isn't it? And it gets really, 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 and starts looking like the tangent line. And h is getting smaller and smaller and smaller and approaching zero. Those 2 points are almost on top of each other, correct? In fact, in here, I think if I put it on top, it disappears. Ooh, look, h is 0. It's not supposed to happen that way, I don't know why it did. But you can see that it becomes a tangent line, okay? So the reason I'm giving you this is because this definition is that graphic. Does that make sense? When I learned calculus, it was very, very theoretical. I had to have an image of what that meant. That's why I put that up there, okay? So when you see that, that's what this comes from a limit. Now, it's a lot of work. So I've done 3 problems for you. The first one I said, okay, if I have f of x equals x squared, what's the derivative? Well, let me do my limit. And so I'm going to write the limit as h goes to 0. I put x plus h into my function and I square it. And then I subtract my function. And I divide by h. So I'm going to do a little work. I can expand this. I can bring on my red pen. And then I can see I got 2 terms, and I don't want to be rushing through this. I have 2 terms that have h in them, so I could factor out an h. And I get 2x plus h divided by h. I can simplify again. And now I'm going to take the limit. I have to take the limit. I have to take the limit as h approaches 0 of 2x plus h, and I get 2x. So this equals 2x. So the limit of this is 2x. And I'm going to do one thing. I'm going to say that exponent is 1. Because it is. Right? Alright, so then I said, because I had nothing to do, I said, what's x cubed? Well, because I had Mr. Eckstein, he showed me a quick way to do this. So I took the limit as x, h goes to 0. I've got x plus h cubed minus x cubed over h. And he showed me how to expand that. It's x cubed plus 3x squared h plus 3xh squared plus h cubed. That's what this is expanded, minus x cubed divided by h. And of course, bam-ba-dee, bam, bam, bam. And I can factor out an h, and I get 3x squared plus 3xh plus h squared all over h. And I can go bam, bam. And then I'm going to take the limit as h goes to 0, a 3x squared plus 3xh plus h squared. This is going to be a 0, this is going to be 0, and I'm going to be left with 3x squared. Did I go too fast? So that means if f of x equals 3x squared, if f of x equals x cubed, its derivative is equal to 3x squared. I did it one more time. Oh, and I don't have a life at home. Okay? I just do math problems all day long. So, f of x equals x to the fourth. What is the derivative? Does anybody have a guess of what it is? Anyone want to take a... 4x cubed is the right answer. Without doing a limit, you got to correct. Do you like that rule now that you just created in your mind?
Yeah.
It's an awesome rule, isn't it? I'm going to do the limit just to show you how painful it is. Okay? So I got the limit as h goes to 0. Now remember, I had to do 150 of these. To the fourth minus x to the fourth over h. And I know how to expand that. I've got x to the fourth plus 4x to the third h plus 6x squared h squared plus 6x h cubed. Oh, no, that's not what I have. It's a 4. Sorry. 4x plus h to the fourth minus x to the fourth over h. And those are gone. I factor out an h. I get 4x cubed plus 6x squared h plus 4x h squared plus h cubed. This is over h. The h's are gone. And so down here I take the limit as h goes to 0 of 4x cubed plus 6x squared h plus 4x h squared plus h cubed. When I plug in 0 here, when I plug in 0 here, when I plug in 0 here, I am left with 4x cubed. That brings us to these notes. The power rule. So this was 2x. I could write it as 2x of the first. Do you have to? No. But it's for a point. This is 3x squared. Jonah said 4x to the third. Besides Jonah, anyone want to take the guess of what the derivative of x to the fifth is? Yes, sir.
5x to the fourth.
5x to the 4th. That's exactly correct. Besides Matthew and Jonah, can anybody tell me how they got that answer? Without doing the limit. What are they seeing?
Take the power that goes in front, and then the new power is one less than the first.
Perfect. That's the power rule. So, if I have x to the nth, Austin, here's x, right? The x doesn't go away, right? And you said to write what here?
The n.
The n. Perfect. What do I write here?
That just be 1.
You said subtract. Well, was a 2 here, a 3 here, a 4 here. You said to subtract how much?
1.
So I'm going to write n minus 1.
Yeah.
Does that make sense?
Yes.
Okay. You know, because 4 is 5 minus 1. All right, perfect. Everybody agree?
Mm-hmm.
So, Colin, could you imagine taking the derivative of x to the 37th power? No! No, you couldn't. You would go nuts. You would be angry. You may not. This is the first time I got you to smile in class. Awesome! You are so pleased with this power rule. It's y to the, and I'm going to write y prime. Everybody okay with that? What is it?
It's 37 next to the 36.
Perfect. That's it. I remember saying, Dr. Tom, you gotta be kidding me. That's all I had to do? I waited 3 weeks in calculus class to get to the power rule after 150 problems, thinking that maybe I should go back and be a welder, or maybe the lobster fisherman job is not such a bad idea. Callum, what's this one? And I'm going to write dy over dx on this one.
9x to the 8th power.
Isn't that great? Now, not so easy of examples. LS says rewrite. So I'm going to rewrite this as y equals x to a power. What? No. It'd be a 1 right here. It's not a 1/2 because it's a -1. Okay? You only get the 1/2 if the square root's in the denominator. Okay, remember, radicals give us, do you guys know what I mean by radicals? That's a funky little symbol, and then sometimes there's a number there called an index. That creates a radical. Only when you have something like that do you ever get fractional exponents, okay? Otherwise, these will be what we call integer exponents, okay? So, now, we're going to apply Austin's rule, because Austin's the one that said this is the rule, right, Austin? Okay? And I'm going to write y prime, Ella. What goes in front?
-1.
Exactly. Do I have to write the 1, or can I just use a negative symbol?
You don't have to.
Yeah, are you okay with that? Because by heart, I am a lazy human being. Okay. X, do I have to write X?
Yeah.
Okay. What about this? It'd be a -2, because a -1 minus 1 is a -2, correct? Which means now I could write this as a -1 over x squared. Does everybody see that? Do you see where the -1 comes from? Do you see why it's x squared in the denominator? Remember, this means go into the opposite location. Right now, the denominator is 1, isn't it? Is that okay review, Grace? Sure? Okay. Grace, rewrite. Y equals what? X to the -4. Notice it says differentiate. What does that mean? Take the derivative. I'm going to write dy over dx. That doesn't scare you, does it? Okay, equals what?
-4x to the
I heard negative and then, okay, you're gonna take -4 minus 1.
Negative.
-5. See, remember when you learned negative numbers? Way, way, way back in the day? Okay, they come back. Is that sun bothering you? Do you know how to operate that thing and lower them? Do I, you've got somebody that's behind you. You have to be considerate. Do you know how to operate that machine? Can you operate it? Lower it, so it's not glaring in their eyes? Perfect. Jonah, you need
Yeah.
that adjusted.
I'll go do it.
You'll go do it? Okay, otherwise it's gonna make somebody do it, but that's fine. This Tyler's like on a roll. Okay, everybody okay? All right. Ariana, rewrite this. Y equals X to what power? Squared? I don't think so. I think it's a fraction.
Oh, wow.
1/2. Okay? Everybody okay with that? Your index here is 2. Why they don't write it in there, I don't know. So that will always be the denominator of your fraction, whatever that index is. Okay? Y prime. What's going to be up in front, Ariana? 1/2. Guaranteed, right? Everybody agree? X never leaves. So now the problem is, what is 1/2 minus 1? Right? Because Austin said subtract, take away 1, subtract 1, right? Whatever n is, subtract 1. Here's n. Now I gotta subtract 1. What do you get? A negative something. You got a half to begin with, right? You're gonna take away 2 halves. Right? Right? 1 minus 2?
Okay, negative 1.
Yes! -1. There we go. -1. -1/2. Okay, everybody agree with that? So I can rewrite this as y prime equals, I'm gonna have a fraction, down here is gonna be a 2, up here is gonna be a 1. Are you okay where I came up with the square root of x on the bottom? This means go in the opposite location, the bottom is the opposite location, and I just rewrote it with its radical, its square root sign.
So x to the 1/2 definitely gives us the square root of x. The negative basically turns that into 1 over square root of x.
Correct.
Multiplying that by 1/2 will give us the 1 on top, and square root of x times 2 gives us 2 square root x.
Correct. And what does this find you? What's the purpose of this? To find the blank
The instantaneous rate, or the derivative.
at any point on the graph,
Yep.
right? Or at any moment, correct? Okay. Rewrite this for me, Matthew. I'll give you a hint, x.
Yes, definitely we will have an x here.
Yep. What power?
I believe we would have a 1/7 maybe?
Well, you got 7, right? Because that's the index, correct?
No, 3/7.
3/7. Everybody okay with that? So this power in here is x to the 3/7. So we're finding the 7th root of x cubed. You can see how that's important because that tells you n, right? And then we're going to apply Austin's rule. What goes in front, Matthew?
3/7.
3/7. X to what power?
-4/7.
-4/7. Okay, so I'm going to rewrite three on on top, 7 on the bottom. Correct? Since this is a fraction, I'm going to have a radical. Its index is 7. X is inside that radical. Its exponent is 4. God, it makes you really like whole numbers, doesn't it? Okay. Can I flip it over?
Yeah, just let me rewrite that in a more clear, concise manner.
Hmm?
Actually, I can write that on my own.
Okay. All right, now, I put this problem in here because everybody screws this up when I have them do it on the quiz. So Owen, I'm going to rewrite it. This is x to the first, correct? This is x to the 1/2, correct? So I'm going back in time. Back when I learned rules about exponents. The bases are the same. You're dividing, right? Remember those rules? It's a long, long time ago.
Star Wars reference.
What do we do with the exponents when we divide and the bases are the same?
We subtract.
We subtract. So I'm going to rewrite f. I haven't even taken the derivative yet. I'm still doing algebra. It's going to be x to what power, Owen? 1 minus 1/2.
1/2.
Half. So now we're going to take the derivative. That's going to be 1/2, we did this one, x to the negative 1/2, or 1 over 2 times the square root of x. That was one we just did just a little while ago, right? I think, Ariana, I had you doing this one, right? Okay, it's okay. Don't worry, I'll forget tomorrow. Okay. So now I can say f prime of 7 is 1 over 2 times the square root of 7. Ben, what is that?
I don't know.
Okay, that is fair. That means I need to do a better job, okay? What does the derivative find for us?
What slope of the tangent line?
So this is the slope of the tangent line when x is equal to 7 on this function, which is simply this. Okay, it's the slope of the tangent line. All right? Okay. So Maria, this means multiply, correct? So this, the cube root of x, I could write as x to what power? 1/3, perfect. Times, that's what that dot means, are you okay with that? The black dot? Do you know what it means on Treasure Island? Ever read the book Treasure Island? Okay. Whenever you got, anybody know the book Treasure Island? Anybody watch the Muppets version of Treasure Island? Does anybody know who the Muppets are?
I do know who the Muppets
Okay.
are.
Do you know what the black dot means in Treasure Island?
Nope.
It means if they give you a piece of paper with a black dot on it, you are not going to live very long. That's not what it means in governance. It means times. Okay. I could see I'm scaring you. Okay, so this is times x to the 3rd, right, Maria? So f of x is x to what power? I didn't hear you. What do you do with the exponents? Okay, what if I had this? Does it mean this? Here's x times x, which is x squared. Here's x cubed, x times x times x. What does that give you? X to the 5th. Pardon? You add them. So what do you get when you add 3, a third, and 3? 3 1/3. Okay? You are absolutely correct. You get 3 1/3. Now, I'm gonna ask you, see, this is like stuff you did in elementary school. Can you make that into a mixed number, excuse me, an improper fraction? 10/3. Okay? Now, can you take the derivative of it for me? What number goes in front, for sure? 10/3. Is everybody understanding that that exponent is going to end up being in the front? Okay? Now here's the hard part. You got to subtract 1, which is like subtracting 3/3, correct? So if you've got 10/3 and you get rid of 3/3, it's going to leave you with 7/3. So f prime of 8 is going to be 10/3 times the cube root of 8 to the 7th power. I could also do it that way. Now, why would I do it that way? Because, Jonah, I have no idea what 8 to the 7th power is. Not a clue. No, nothing. But I can tell you what the cube root, because cube is like, it's a 3. So it's got to be my realm of favoritism, right? So I know what the cube root, what number times itself gives you 8 3 times. What is that?
2.
2. So this is going to be 10/3 times 2 to the 7th. Well, I got 2, 4, 8, 16, 32, 64. I'm just doubling, right? 128. So this is 10/3 times 128 over 1, which is 1,280 over 3. And I know you guys would probably do that on your calculator, but I was just having fun. Parallel tangent lines. What do you know about slopes of parallel tangent lines?
That'd be the same.
They have to be the same, okay? So, is x to the 4th a derivative? Does it say it's a derivative?
No.
No. Can you tell me its derivative?
There'll
Yeah.
be 4x to the 3rd.
4x to the 3rd. What does that give me? That gives me the slope of the tangent line at any value on x to the 4th, correct? Any of them. Here's g of x is equal to x cubed. Tyler, what's the derivative of g?
3x.
This gives me any slope on the tangent line on g that's for any value of x, right? This is what I would have to do. If it was at 1, I'd have to plug a 1 in here. Okay? Now, it says, at what values of x do the graphs of f and g have parallel tangent lines? What should I do? Set them equal to each other, right? Here are all the slopes of f, and I want to know where they're all equal to the slopes of. Now, if you divide by x squared, you lose an answer. There are 3 possible answers to this. How do I know that? How do I know that there are 3 possible answers?
The exponent,
What exponent?
the largest one,
Exactly. Which happens to be a what?
3.
Right. So I mean, I'm going to end up doing this. I'm not going to divide by x squared, but if I divided by x squared, then this would become linear rather than cubic, correct? Right? Would everybody agree? And when it's cubic, It can do that. It could cross the graph at 3 times. It doesn't have to. It's either got it's got to go through it once, right? Because it's odd, because one's going up and the other one's going down, right? It's got for sure 1. It might happen 2 times, but the most it can happen is 3 because of the highest power. That's exactly correct. So I'm going to make this equal to 0. I'm going to factor out an x squared. That means either this is going to equal 0 or this is going to equal 0, correct? So I let x squared equal 0 and x equals 0. So for sure, at 0, and you think about it, if I plug 0 in here and I plug 0 into here, I get 0, don't I? So at 0, they're parallel. What kind of line has a slope of 0?
Horizontal line.
Horizontal line. So these are 2 horizontal lines that are parallel to each other, right? Then I'm going to take the 4x minus 3, make it equal to 0, and I'm going to get x is equal to 3/4. And if I plug 3/4 into here and 3/4 into here, I'd get the same answer. Are you okay with that?
Mm-hmm.
Everything okay?
We still need one more.
What'd you say?
Don't we need one more x value?
No, this cubic only touches the x-axis as 2 places. The most you can have is 3.
Oh.
You're not guaranteed 3.
Oh.
You're guaranteed 1 for sure, because it's an odd function, which means it goes in opposite directions eventually. Okay? Does that make sense?
Yep.
Okay. Everybody okay on this? All right. I probably should say hi to Audrey, so she knows we're listening. All right, I just got a few more rules. Oops, sorry.
Yeah, it's fine.
You wear a different crazy pair of socks every day?
Yeah,
Pretty much. Good. All right. So, derivative, we're going to do 3 rules. They're going to be nice. Okay? First one is a constant. Okay. Let's see. What constant am I thinking of, Grace?
3.
Yes! Perfect. Okay. Could I write that as 3x to the 0? Because it's 3 times 1, and x to the 0 is 1. Everybody agree? Austin, we're going to apply your rule. So when I take the derivative of this, I'm going to have 3 times 0, correct?
Yes.
Because that's what n is.
Yep.
Times x to the negative 1. Would you agree?
Yeah.
What's so special about this thing right here? That number, 0,
Makes everything else 0.
it kills absolutely everything. It's like bleach. So, when I was first married, I'm very much in love with my wife. But at that time, I would do anything for my wife. So I said I would wash the clothes. How many times did I wash clothes? None. But I had to wash clothes. It can't be that complicated. And my wife had this beautiful spring dress. It was kind of reddish and blue. And so I said, I'll wash it. I'll wash the clothes. I put the clothes inside the washer, and I got a jug of bleach, and I poured it into the washing machine. You guys are all laughing. I ruined her dress. Because bleach kills color. Just like the number 0. So what's the derivative of 3? 0. Because like Austin said, it doesn't matter what any of this other stuff is. When you multiply by 0, everything else is gone. So anytime you have a constant, the derivative is 0. And if you think about it, if you were to draw a constant, it's a horizontal line. And if you put a tangent line on top of that horizontal line, that slope is going to be 0, correct? You scared me, Jim.
I think Ashley was just on this one. Thank you.
Okay, give me a second here. You guys are watching this, I'm sure, with big intent. All right, back to here. Everybody okay with that? Anytime you see a number, its derivative is 0. Now what does it mean by this? Well, let's say
I kind of don't understand the d of x of c equals.
yeah, derivative of a constant with respect to x. Derivative, so in other words, y is equal to c. So we have dy over dx. We're replacing y with c. Does that explain it?
I think so, since we're separating it, so d since c over 1 is just d of.
Right, and I could write this as this. Is that better? That's a good question. I'm glad you asked. Right, so what does u mean here? Well, u just means it's an equation, so I'm going to make the equation x cubed. And c is going to be some constant, I don't know, I think I'll pick 3. So I'm taking the derivative with respect to x of 3 times x cubed. Well, according to Austin, I'm going to have a 3 here. I'm going to take this derivative first, times 3, right? Because it goes up in front, x squared. But what's 3 times 3? 9. So this is 9x squared. Now, Austin, you're saying, I could have just taken 3 times 3 and come up with 9 and subtracted 1. Yes, is the answer to that. So if I would have y equals 5x to the 4th, its derivative would be, well, this is going to drop down to 3. I'm going to take that 4 and multiply it by
5.
and get 20. Does that make sense? That's what that rule is saying.
So we multiply the coefficient times the exponent to get our new coefficient, then do the exponent minus the old exponent minus 1.
Right. So exactly what he said. You're taking that exponent, timesing it by the coefficient, and still subtracting 1 from the exponent.
Does this apply to finding the jerk of a positional function?
It could be.
Finding the third derivative of a
Yep.
positional function, aka the jerk?
Yeah. All right. The sum and difference means that if notice I have 2 functions here. So let's say that y equals x cubed plus x squared. Well, that means its derivative would be 3x squared plus 2x.
What does it say, y to the what?
I have y equals,
Like under the u plus
Yep.
minus v, what does that say? Y
You
to
see-
the first.
Oh, this is y prime.
Oh,
That's why it looks like a one, because I didn't make it slanty enough. So you just take them, the derivatives individually. Okay?
Yep.
I don't wanna make it too simple if there's something I needed to do a better job of explaining it. Alright, so if I look at this, the first thing I do with
I
this,
still zoomed in.
yeah, thank you. The first thing I do with this, I'll make it a little bit bigger there. Is I'm gonna write this as 2x squared minus 5x to the negative 1 plus 6. And then when I take its derivative, 4x to the first. 2 times 2 is 4, I subtracted 1, if you want to write the 1 there you can. Plus 5x to the negative 2. So I took the negative 1 times the negative 5, it became a positive 5. Subtracted 1 from the negative 1, got a negative 2. The big mistake is people forget to take the derivative of 6. What's the derivative of 6?
0.
0. So I would rewrite this like this. Ben, okay?
Yeah.
Okay. Do you, Ben, I'm gonna rewrite this, 8x to the 1/2. Now, you'll see me do this every single time. I'm dividing by 3. I write that as a negative 1/3 x to the 6. I write it as a coefficient. It makes it a lot easier. Plus 2 pi to the 5th. So dy over dx equals Ella, what am I going to get here?
4x to the negative 1/2.
Perfect. Jonah, what am I going to get here?
Negative 2x to the 5th.
2x to the 5th. Perfect, right? You'll get 6/3 here, which is 2. Owen, what will I get here?
I don't know.
Anybody have an idea what you get when you take the derivative of this?
0.
It's 0. Why?
Because that's just like a number.
Yeah, it's a crazy number, right? I don't even know what pi to the 5th is times 2, but it's a number, right? It's a constant, so when you take its derivative, it's 0. And guess what? Not knowing's okay. You've never seen this before. And then all of a sudden you get a crazy number like that. It's a number. And when you take the derivative of any number, it's gone. So my final answer would be this. 2 over the square root of x, excuse me, 4, you said 4 inches, sorry, minus 2x to the 5th. All right, horizontal lines are a big idea, big. When does a function have a horizontal tangent line? The slope of a horizontal tangent line is 0. To find where a function has horizontal tangent lines, we set the derivative equal to 0. So I'm going to take the derivative. And Callum, what will I get when I take the derivative of this quadratic?
I'm not really sure.
Okay. Let's just look at this. What are you going to do with this 2?
Subtract by 1.
Okay, so it'll become x to the first. Anything else I do with that 2? It would normally be out front here, right?
Multiply to the 4.
It'd take 2 times 4?
8.
8. Perfect. Perfect, perfect, perfect. Okay? What about this? Remember, it has an exponent of 1. So it's going to drop by 1, correct? Become x to the 0, which is 1, right? So I'm not even going to write down x to the 0. And then I'm going to take that 1 times 7. What am I going to get?
7.
7 plus 7. What do I get when I take the derivative of minus 13? 0. Everybody okay with that? And now I'm going to make this equal to 0. Because I'm looking at where there are horizontal tangent lines. This is the derivative of f. This tells me what all the slopes are on this quadratic. I am looking for a particular slope. What slope am I looking for? 0. So I'm going to solve for this, and x is going to, I'm going to subtract 7, divide by 8, and get a negative 7/8. So at a negative 7/8 on this function, I get 0. Let's go to the machine, because the machine never lies, right? And I'm going to put in 4x squared plus 7x minus 13. Then I'm going to quit. And I'm going to go, oh, I could do it up here. Second enter. And I'm coming over here. Delete, delete. And I think it's a negative 7/8. 0. Ha! I did it right. And faster than the machine. Look how much work it took me to type all that stuff in. There's the machine. Okay, a normal line goes through the same point as the tangent line does, but is perpendicular. What do I know about perpendicular lines? Parallel lines have the same slope, right?
Perpendicular basically is the same line but rotated 90 degrees.
I would agree. What about the slopes?
I believe they'd also be rotated 90 degrees. But I am not 100% sure since it's been so long since I've dealt with this stuff.
Okay, anybody hear of negative reciprocals? So perpendicular lines have negative reciprocals. That means if you multiply the slopes, you get a -1. Have you ever heard of that?
Probably, but it's been so
So
long.
find the equation of the normal line. Well, they're going to intersect, so I have to figure out this. What am I figuring out by doing this? Right, it says that x equals 3. I need an equation of a line. What do I need? I need a point and slope, correct? Right? Did you agree? Okay. So what am I doing when I'm plugging 3 into here?
Finding a point.
What part of the point?
The y.
The y value, correct? Well, I've done that for you. I plugged it in and got 27 minus 36 plus 3 plus 3, and that came up, believe it or not, Grace, a -3. Isn't like that the coolest thing in the world? So my point is 3 comma -3. It's almost perfect. Now, so my point is 3, -3. Now I gotta have the slope. How do I figure out the slope? I find the derivative. What's the derivative? Owen. What's the derivative of x cubed?
3x to the square.
Correct. Just do one at a time. Minus. X will be to the first power. Correct?
Yeah.
Right? 2 minus 1 is
1.
1. and then you're gonna take that 2 and you're gonna multiply it by 4. What's that gonna give you? 8. Bingo, perfect. Now you're gonna come over here. Here's a 1, right? You're gonna subtract 1. It's gonna bring you to the 0 power, right? Which means x is gone. It's now number 1. But you're gonna take that 1 times this coefficient here, which is a 1, and you get a 1. So plus 1. What about this 3? 0. So this is my derivative. I'm going to plug what into it? What x value do I have? 3. So this is 27, because 3 squared is 9, times 3 is 27, minus 24, plus 1, and I got 4. Everybody okay with that? So the equation of my tangent line would be 4 times x minus 3 minus 3. The equation of my normal line still means I still have the same point, but my slope is different. It's the negative reciprocal. It's going to be perpendicular to that line at the same point. So what do I put in here? What's the negative reciprocal of 4?
Negative 1/4.
A negative 1/4. These two lines right here are perpendicular. Here's my point. Here's my slope. I changed it so it have a perpendicular line.
So we just changed the 4 to the first power to 4 to negative first power.
Right, and you have to make it negative. Right. You have to have the opposite sign too.
Okay, I think I got it, but I'm not sure.
Okay, so if you have two slopes, I'll call one slope 1 and slope 2. It has to, when you multiply them together, for them to be perpendicular, it has to equal a negative 1.
So if I put it in the calculator, I got the derivative of one number.
Yeah, let's say you got a derivative of
Like
3
5.
halves.
Or like 3 halves. We put equal times unknown equals negative 1.
Right, so you're gonna flip it, right? 3 halves would become,
That would be
you're gonna interchange the x and the y.
that would be 2/3.
2/3, but you need to have the negative, then you gotta make it a
Negative
negative 2/3. So let's say you had 5, you'd have a negative,
You'd have a 5 times a negative 1/5.
correct, okay?
That makes sense now.
Does that help? Okay, good question, alrighty. Alright, let me give you your assignments. Really? I made them the same color?
Mr. Cooper, how about the back?
Oh. Let's go to the back. All right, so it says, is the function differentiable at negative 1? So here's number 5. The first thing I have to do is I have to make sure it's continuous. So what I'm gonna do is I'm going to take a look and I'm gonna plug a negative 1 into f. So do I choose this top expression or this bottom expression? Which one? The bottom. So when I put in the bottom, I'm gonna have a negative 7 times a negative 1 minus 3, and I get what?
4.
4. Everybody agree? That is also the limit as you approach negative 1 from the right of f of x, right? That's also 4, because it's to the right. Correct? So, I'm now going to take the limit as x approaches negative 1 of 5x squared plus 3x plus 2, and I'm going to approach it from the left. So I'm going to put that in there, and that's going to give me 5 minus 3 plus 2, right? Because I'm squaring a negative 1, which makes it positive. This will be a negative 3. What do I get here? 4. F is continuous at x equals a negative 1. Now I'm going to take its derivative. And its derivative will also be a piecewise. So when I take the derivative up here, I'm going to get 10x plus 3, the 2 is gone, for x less than a negative 1. Does everybody see where I got the 10x? 2 times 5 is 10, subtract 1 from 2. You see where I get the 3? 1 times 3 is 3, subtract 1, you get x to the 0 power, you're left with 3. We'll finish this tomorrow. Okay?